Yes, I came from Poland, although not directly. I started my journey today in Germany, in München, so sorry if I make some silly jokes, but that's on me. I owe you an explanation with this name and everything, right? So speaking of that, because there are two things. First, this is from official Polish government page, right? So if you see so-called Polish smile, this is basically it, right? So natural expression on a street, right? It's like you don't smile in Poland because things are like neutral and so on. You smile with your friends, family, but so this, lady on the right, on the right is seen as a natural facial expression, right? This is what it says, right? That's unnatural in Poland. If you just go in and smile on the street and it's like you're not talking over a phone or something, people will assume you just... And the other thing about the name, I tried to book a flight with with an airline, and its name starts with L and ends with Lufthansa, right? And this is what they gave me, right? So in German, it's even funny because in German, Y, right, or Ypsilon, as they say, it's not a vowel. So I have in German, I have 7 letters in my last name, all are consonants. So I have a nickname, Piotr ohne Vokale, vowelless Piotr. And to just read my name in Polish, which is very, very common name. I mean both the first name and the last name. It's sorry, I need to quit my. You didn't see this. It's Piotr Przybył, right? So it's like Peter, Petros, and so on. Yeah, enough chit-chat. Let's talk about the topic at hand today. I work for a company called Elastic, for search. A senior developer advocate. I'm also Java champion, test containers champion. You can find me on various social media platforms. John just found me on LinkedIn. The clicker should be working. Does it work though? Yes, it does. Cool. This talk is going to be around AI, right? And the bloody AI summarized me some time ago. I'm afraid it doesn't say that much here, so let me just read it for you. An edutainment powerhouse blending programming wisdom with genuine humor. So if you suffer from dad jokes, this is now time to leave the room. I'm sorry. I also hate to be the last talk during the day, because then it means I'm the last thing between the conference and the dinner for you folks, right? So I'll try to run through it as fast and as smooth as I can. And it says, as you can see, it's Java, right? So I'm mostly Java. So that raises a question, because I have prepared a demo for you today. What programming language was used to create this demo? Don't be shy. No, not Java. I mean, that's close, but not Java. Any other? Now, everyone, AI, it has to be Python. No. C, no. Ruby, no. Go, no. No Rust. No, not Pixel. Okay, I'll spare it to you. It's going to be in Bash. It's going to be in Bash, right? So who are you? Who's Java developer? All right, who's not a Java developer but still developer? Okay, cool. So what languages do you folks use? Python? JavaScript? .NET Stack? Rust? See, there are no Rust people in the room. Okay, cool. So we know each other. Very nice. Little warning, it's late. I woke up before 6 a.m. I'm tired. I might slip some words, some funny words into sentences. So I might just talk funny things. And also, it's all about AI. So what we know today might be invalid in like 2 weeks, right? Because someone will release yet another great model or whatnot. So keep that in mind, especially if you're watching the recorder. Okay, Java people. Do you know this thing? I asked ChatGPT some time ago, what are stream gatherers in Java, right? I asked this question, and this was the answer, right? Stream gatherers in Java refer to technique, blah, 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 blah. And then it tells stream collectors list. That's Java 8, right? So it didn't give me correct answer, the answer I was hoping for. Okay, sorry. Yeah, so it's not really stream gather, which is addition to modern Java. We'll be talking about this, Marit and myself, tomorrow in this very room, 10 something, so please come and join us. And this is the problem, right? AI, the bloody AI is trained for something, and then comes the actual use case and problem. It, as we say, it hallucinates, right? It tells rubbish or something like this. So how can we approach this, right? Or how can we avoid having this problem? So this is, I asked this with ChatGPT 4, I guess, and I asked the question, what are stream gatherers in Java again, right? Because the previous one was ChatGPT 3.5, and it started saying something like, again, Java util stream collectors, blah, 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 to map, to list, grouping by. This is not what I wanted, right? And then I slightly modified this thing. And out of the sudden, I started receiving correct answers. So it says gather, right, and this initializer, integrator, combiner. As far as I can tell, this is correct answer. So can you tell me what's the difference between these two? Who said search? Okay, yes, very nice. I brought some nice elastic swag. Let me just find it for you. Okay, where are you? Where are you, the swag? Yeah, it's this search. So by the way, there's like stickers. I brought for you stickers. They're on this chair, right? So please help yourself after the talk. This is for you. Okay, yeah, the difference is search. So when ChatGPT is able to search the web and find the information it wasn't trained on, right, then suddenly it's able to give correct answers. Because this is the problem with AI. It was trained on some data, some language corpus, right, whatever, and this is the cutoff date. So when it doesn't know that, it starts hallucinating, as we say, only it doesn't know it hallucinates. And this is pretty much like not just ChatGPT, sorry, when I say this, I mean all the LLMs, right, the generative AI and so on. So this is the thing. So, for example, there's also another issue. It might have been, for example, you're asking for something that it couldn't have known ever. Let's say you have a company policy, and the company policy says when you're getting married, you are allowed to take, for example, 2 days off or a week off, right? Or, I mean, okay, I guess in Greece, guys, you have very long weddings, so maybe even more. Yeah, but the point is, ChatGPT cannot know this because it doesn't have access to your company's wiki page. So what we need to do is basically to make sure it knows about this stuff, and this talk is about how can we make this happen, right? Yes. By the way, I'm a huge fan of translating English terms into your mother tongue, because then, you know, when you say RAG or retrieval, augmented generation, it sounds like very super fancy poshy, but like maybe you're missing what the actual meaning is. I really hope this is correct Greek. Right, and also with your, like, from any country around, it also makes sense. In Polish, it very much makes a sense, right? It gives you what it actually means. So maybe let's use ChatGPT to better understand, like, what the whole bloody AI revolution is all about. Yeah, so let me get you through this retrieval augmented generation. And I will try to run an experiment, which is running on my computer only. It should be offline. It will be using some Elastic, but free version, open source version. Elasticsearch is open source again. And for this, you know, matter, let me just word my lab code, okay? I'm not a doctor. I'm one of these, you know, scientists that do some wild experiments. And I mean, I couldn't bring a lab code for every one of you. But let's assume everyone now wears this lab coat, right? And we'll try to experiment. Things may break, so we'll see how it goes, right? So the whole purpose of retrieval augmented generation is to have the right answer. So when you ask it, right, for example, how many holidays I'm allowed, or PTO days I'm allowed to get because I'm getting married or my son is getting married, right? We need to get there, and the LLM doesn't know. So, of course, to get this answer, we need to ask the LLM, right, for something. And how it works, for example, it's quite simple, I hope. Let me show you. Let me show you here. I should have a script, a simple script, which is, where are you, script? See, I have bash source. There are, of course, Java sources for like, if you're into like Java or something, but I should be using this written in Bash. And as you can see, I have Olama running on my computer, right over here, and I have a model deployed, which is DeepSeek, just for sake of experimenting. And what I'm doing is really, really simple. You see, I'm making just this zero post call, right? And I'm telling, or generate the answer using this model, and tell me what are stream gatherers in Java. And I can also toss options when I'm sending something or requesting something from these LLMs. There are many options. I have just one here, which is the temperature. How to explain temperature? This is not scientifically correct explanation, but I introduce it as the YOLO factor, okay? So when you put the YOLO factor at 0, this is like you want it to be extremely factual, like don't make up stuff and so on. Very nice in like law, medicine or something. Whereas when you put the temperature like 10, you get like YOLO, basically, like have fun, cat images and so on. So I chose like a moderate one, 0.6, and let me run this script. Let's see if it works. Nice, not this thing. Oh, it didn't preload. Okay, so sorry, I need to bear with me. I have to go to src main bash, right? And I have to source like access key URLs and so on. And now let me try this. Generate 0. And does it work? Or did I hit enter? Now I did hit enter. And it has to like warm up a little bit, right? Yeah, but this is what you get. This is basically the streaming answer, and it's maybe difficult for you to see what it does, right? But as you can see, this is just a pure call, right? You don't even need a fancy library to implement this. The whole point of this talk is to show you that you don't need to have any fancy machinery. If you can just make a few HTTP calls or networkers, you're good to start using AI or LLMs, right? So let me just go with this, and maybe now it would be a little bit clearer what it does or how it operates, right? With this thing, you see, it's so-called like reasoning or something. Okay, so I'm trying to understand what stream gatherers are in Java, right? They're part of Streams API introduced in Java 9. It's hallucinating. It was introduced in Java, Streams API was Java 8, right? And it's not part of it, and so on. So it's basically just giving us rubbish, right? So we don't want to get this stuff. We're done with this. So having just the LLM running locally or someone in the internet is not enough, right? What you need, because it was trained on this public data, and there was this snapshot, right? If it has this capability like modern ChatGPT, so we can go and get this data, maybe we're fine. But let's say this is still your corporate wiki, so it won't have access to it. So what we have to do, we have to get this data for it, right? But maybe we can start with this approach first. And I happen to know that there is a thing called the JEPs, which stands for Java Enhancement Proposals. And what I can do is this. I can go fetch this page, see HTML content, basically whatever is like the visible, right? I can prompt what are stream gatherers in Java, just like I did before, but I can also build the context, right? So I'm just telling, given the context information provided below, and this is the HTML context, answer the prompt, right? And this is it. And let me try to run it now, and let's see what happens. That should be generate 1. Okay. And the JEPs page has a bloody timeout of 10 seconds. That's why it takes a little bit more. Yeah, we see that this is the prompt, right? Displayed, you see with these dashes. And now it's a pretty big context. So my local LLM running on this very laptop has to crunch it, right? Maybe I'll try to connect it to power. Maybe it will get more juice and then try to answer faster. We'll see. Yeah, it's still taking some time. Yeah, but okay, see, it says, okay, I'm trying to understand this concept called gatherer and so on. Yeah, it says something. Let me just quickly see if it makes sense what it says. Yeah, it's giving me correct answer, right? Let me stop it here. It's giving me correct answer. So it's about this integrator, initializer, and so on and so on. So it was able sort of do the same thing that the ChatGPT with search is doing, right? Only I knew the URL, I fetched the data, right, and tossed it as the context, right? The thing is, you have your business data, and imagine it's not like the wiki page; it's like a printed book, and you can't pass the whole book to the LLM because it is too costly. It's too many. You see, just having one HTML page or when you just run it locally can basically make it store for a moment and so on. So what you need to do is just to figure out how to get, these 2 pages which are relevant, right? Sort of like take them out from this book, pass it to LLM. So this LLM, let's say it's intelligent enough so it can understand these 2 pages, and based on the stuff it was trained on, plus these 2 pages, it could give us the right answer, right? So we need to get this data, and also how do we get this data? And this is the interesting part, right? We need to have this retrieval mechanism which will allow us to get the stuff from our business data. So when I ask these questions, what are stream gatherers in modern Java, right? It needs to get it from a database somehow or find it on the internet. And this is it, right? So we need to have this question and context window. Only instead of going like serial public stuff, I'm going to get it from my local vector store. And of course, for vector store, I'm using Elasticsearch. Let me see if I can open it now for you. It should be running locally. Local host, the Germans say local host sometimes, sorry. Yeah, and it's like, as you can see, it's running on my local host. If you also want to run it something like this, you have to go and search for Elastic start local. It will take you, not this. Yeah, this Git project, right? There's a single bash command. You just need to have Docker or WSL on Windows, and that's it. And you run it locally just as I do. And what I have prepared before this talk is the following. I have an index called myIndexJEPs. And this index was created, you see it has mapping, so it's body, headings, title, URL, and so on. Basically, I crawl the page of the JEPs, right? And the crawler has put it into my Elasticsearch. So when we go and see the pages, right, the documents that represent the pages, like this one, for example, you can see there is like the body, headings, links, everything. And this is just text, right? The thing is, this kind of search might not be able to do what you need when it comes to what? I'm sorry. I'm not sure what's going on. It just got the internet. Sorry, I will, I'd rather do offline. Sorry, so without you like lurking. Come on. Cool. This never happened to me when I was giving a talk so far. And now it also refuses to read my fingerprint. Gosh. This wasn't expected. See, that's why I say the demo gods sometimes aren't with you. Does anyone have any dad jokes?
This is what's happening in science, right?
Yeah, exactly. Sometimes the experiments don't work.
In science lab.
Let me try the other browser. And yeah. I've learned a great dad joke in Colorado last year. Are you guys into Star Trek? Yeah, like volcans and so on, yeah. Do you know how many years Captain Kirk had? No. 3. Let me just run the slides first. Okay, because I don't want to spoil the answer. I've never done this, like switching the slides live. You have... okay, sorry. Gosh. Now it's even getting hotter in Greece, you know, when you're on stage and the stuff doesn't work for you. Come on.
Please give an applause to make it work.
And it did. Thank you. Sorry. So Captain Kirk had 3 ears. Left ear, right ear, and the final frontier. It's that bad. Sorry. Yes. And the whole thing with this search, let me get back on track now, is this. How you get this context right based on your question from your business data that got indexed into your vector store or like knowledge database, right? Because context is the key. If I say football, for you it's this guy or this guy. Exactly. When I say it in the US of A, it's this guy. So see, context is king, right? That's why there's this contextual search, semantic search, and it's usually based on vector search. So let's do a quick recap what vector search does, because it's oftentimes the foundation of the RAG. Does anyone recognize the language? Yeah. And then, so let's say you have this ultimate search bar, like search interface, and the user entered some text, and you created this lovely query. And now the thing is, did they enter milk chocolate or chocolate milk? Because both would be found by this query, right? But they into something different, right? One wants to like a bar of chocolate, the other wants to a drink, a beverage. So this is, you see, where things become tricky when it comes to search. That's why we need to grasp the meaning of the query, and then based on this, find relevant, these pages in this book which are relevant, okay? So vector search looks more or less like this. If you have just one dimension, we can say that Princess Leia is sort of realistic in a galaxy far, far away, and this cartoonish Darth Vader is not. That's why they are on the opposite ends in this spectrum. It is one-dimensional vector, right? However, there can be more vectors. So, for example, this droid is realistic machine. Let's say it was in the movie, right? Whereas, sorry, I always forget this guy's name. Obi-Wan, yeah. Sorry, I'm a Star Trek guy. Yeah, so, and he's human and cartoon, right? And turns out that Darth Vader is somewhat between human and machine. Why? We all know. Right? Okay, but then let's go even further. Let's adjust it a little bit. Okay, let's say he's a bit more machine than human being, right? But then we have Luke. Sorry, I forgot the name. This guy, okay? And he's not as human as Princess Leia is. Why? Yeah, because he has artificial hand. Very nice. I will pass you a swag, Loic, after this, okay? Make sure you catch me. Exactly, that's why we say he's like 0.8 human. So now you see we have like pieces of document, images, and we put this in this vector space, which is just 2 dimensions, mind you, right? And these dimensions can be like 384, 512, I don't know, 4K, whatever works for you, right? And then when I create an embedding, you see now I'm calling API embedding, and I say something, and there's this sentence, quick brown folks jumped over a lazy dog, I get this vector embedding. This is basically an array of floating point numbers, usually. Not always, but usually, right? And then I say over lazy programmer, because we programmers can also be lazy sometimes, right? What you see, and this is also an important thing to know about vectors, it's not that just the numbers at the end of this array or list change, right? The whole meaning, according to this model, might be in a slightly different place. That's why you see virtually all the numbers changing, right? All right. Do you recognize the scene? Matrix, exactly. Matrix, that's the Matrix. So let's say this is the reality or the movie scene that we have to like grasp the meaning of, or the model should do that. And this is the vector representation that Morpheus and Trinity and the rest of the gang saw, okay? It's the easiest explanation of dense vectors I could think of. And then let me show you how it works in my code. I should have here another file which is called encoder, I guess. So let me run this encoder. Yeah, and let's go what are stream gatherers in Java. All right, and see, it gave me this list of these numbers, right? And it's this thing. So as you can see now, it's calling. If I went there, basically it's doing the same thing, right? In this embeddings sh, it's doing what? It's just giving me this list of the numbers, right? And because I call this API, which is like API embedding something in my local Olama. It's another model. It's not the one that generates. It's the model that I give it a prompt. It gives me the embedding. Sometimes the models can also understand, like you give it a sound, it gives you an embedding. You give it an image, it gives you an embedding as well, right? Sometimes they do two. We'll be demoing that with Mari tomorrow. So we have now vector representation for our query. So what we need to do is to run the vector search. And I'm using today Elasticsearch, which is based on Lucene, right? This Apache library, and it will give me, it basically acts as a vector database. So it's not only like, this keyword search or something like this, it's also a vector search these days. And how it works is this, so we can ingest like various types of data, like documents like I'm showing today, or like images or audio. I have then vector representations calculated either inside the cluster or outside, and then I can use the nearest neighbor search algorithm based on this, that the query is translated to the single vector representation, like you just saw, and then it basically compares these numbers to find the most accurate hits. Right, this is how it works. It can be a nearest neighbor. It can be, I guess I broke the captions. Sorry. Or we can do like brute force if we have small vector database and stuff like this. Important stuff. You should choose the right model for your domain, okay? If this was my domain, this model wouldn't be great. Why? Because I have, let's say, overcrowded vector representations here in Europe, or here, I don't know why, in New Zealand, right? Or here, let's say, in South Africa, but here is nothing, here is nothing. Okay, maybe in Alaska there is nothing, I don't know. But you want these vector representations to be spread more or less evenly, because if you have to find, for example, let's say, Amsterdam, is going to be difficult in this crumbled space, in this crowded space, sort of, right? The other thing is, if you chose one model to generate embeddings to store them in your vector database, please make sure you use the same model, or at least compatible one, right, when you translate your queries. Because you can't take a triangle, which is like in this dimensions, right, which is like, let's say, flat map, Mercator, like casting, whatever it's called, and you can't put it on a round globe, because it doesn't make sense. Okay? So just because, let's say, two vectors have 500 dimensions, you can't interchange them. Okay, you need to stick to the model and like similarity metric and so on. Okay, so let's go to the query now. So if I run this query, and the query is Han Solo, this I know, haha. So what would be the list of answers? Something like this, probably, right? Because he's human and he's realistic. So in our vector database, Princess Leia is the closest match. Right, and then it's Luke, right, and then Obi-Wan. Actually, see, this is like the most. It's actually the opposite, right? So the least similar match. So now we should have everything to run our RAG, right? We now have the query. We can run the search and get the stuff. So let me now run this search so we get a proper context window. Let's do this, and then as the last step, we will run this thing. Are there any architects in this room? Are you an architect, IT architect? Yeah. Do you like this diagram? Yeah, exactly. I was told every architect in the world loves this diagram because they are arrows and they animate. Yeah. Okay. Let me go then for vector search. So let me run. See, I have the vector search script here as well. Let's go vector search. It checked that it can connect to my local Elasticsearch, to my Olama, right? And let me like put this prompt. What are sorry, I cannot type. Stream gatherers in modern Java. And now, as you can see, it pretty quickly found me like 3 hits in my Elasticsearch database, because I did along the way something that I call myself enrichment. I ran this script which is called document enricher. It's somewhere in here. Yeah, and what it did is this, because there are different ways how you can run this. Here, let me go back to the list of indices again. So as you can see, I have 2. So in this second one, I have body chunks and I have title embedding as well. So let's see what actually happens there. If you try to express, let's say, the whole book using 500 numbers, it's going to be rubbish, obviously, right? So what you need to do, you need to divide this book into smaller pieces called chunks, okay, in English. And I divided my body of these pages basically into passages, which is like, let's say, 300 to 400 words, characters or words, I forgot, sorry. And then I just make sure these are like full sentences. Sometimes if it's, for example, legal text, you want to divide it by paragraph, it really depends, right? And I had to do all of this manually or in my bash script. If I was using a commercial version of Elasticsearch, I could just use, let's say, semantic text field type. But yeah, so what I have here, see, is this passage, right? And this is very suboptimal way because I'm doubling stuff. I could just keep like the start of the passage and end of the passage to get basically substring, like two positions of the string. And I have this passage, and for this very passage, I have its vector embedding, right? And then for the next passage, once I scroll down, I have another passage, I have another vector representation. So basically, when I have my retrieval strategy here is this. When I have a hit in a document in one of its passages, I'm passing the whole document into my context. And I had hit like in these 3 documents, right? So that's why I will be passing them to the RAG. And let me do the ground finale, which is calling the RAG sh entry prompt again. Sorry. What are stream gatherers in modern Java? Yep. And now this is the thing. See, the search was that fast. And these days, if you optimize it, like put like proper index, like options, it can be actually on par with keyword search, right? Especially if you're running the latest Elasticsearch. And now, as you can see, getting the answer can take some time, which is maybe time for another dad jokes. Do you know why do we call medieval times the Dark Ages? They had a lot of nights. It's that bad. I'm a bad joke connoisseur. I'm sorry. I can't help it. Yeah, but what you can see now, we're getting now the right answer, right? So it says gatherers window fixed. There's truly such a gatherer, right, in the latest Java, right, and so on. So it's giving us an answer which is not a hallucination. It's more or less accurate. It's on point, right? So we have basically, my friends, I don't know why I have to like keep clicking this, sorry. We have implemented this, right? So we used vector search to build a proper context window, and along with our question, we passed it to an LLM, which is running locally on this very laptop. That's why it's so slow, probably. And we're getting the right answer. So this is basically the RAG. RAG can be seen as basically a pattern, or sort of like, I don't know, maybe not design pattern, but architectural pattern. You have to retrieve some stuff to augment the generation done by an LLM. And that's really much it, right? And then the second thing is you can run it or write it, as you can see, even in Bash. Right? So you don't have to say, oh, boss, we have to go for Python or Rust or whatever, or we have to go for these libraries. Sure, these libraries will help you, right? I'm not telling you you have to write it in Bash, but the fact that you can write it in Bash means that you can write it basically in any programming language, right? It's not Python only thing, okay? It can be written even in backend inerts. I'm pretty sure it will work in Perl as well, all right? The question is, should I always RAG? I like this question, and I've been asked this question every now and then. Let me get back here. See, it gave me the answer eventually, but do you remember how fast was this returned versus how long it took to generate all this? So maybe what you need is actually, for example, vector search. If you find these documents, right, and you just give it a clever human being, clever person, maybe they can just quickly read it and they don't need to generate more CO2 and spend CPU cycles on generating this answer, because humans, believe it or not, are in general intelligent beings, right? Not your neighbor, I know, but in general. Yeah, I cannot into Safari, so sorry. So probably not. It's not always, right? Also, some people say, "Oh, I don't need RAG because my like knowledge base is really small. I can always pass it to the LLM." Then I say, if it's that small, you can always pass it to the LLM. You're either very, very rich, right, and you can operate very expensive models, or it's really that small that again, even your neighbor can understand this, right? You don't need AI for this stuff. But people ask me also, what about this MCP? Because MCP is recently a thing, right? What about this MCP? So now these two rather distinct or different things. There's RAG and there's Model Context Protocol, right? And both help large models to access this external information, but in different ways. RAG is basically this. It's retrieving relevant text or data and injecting it into the model's prompt, right? So you can say, fetch the right info, and they use it to explain something in this generation phase. Whereas MCP is just a protocol, right? And it can interact with many things, right? It can do stuff. It can take actions. For example, send an email, run an update in your database, or something like this, right? And the thing is just to connect safely and act through trusted tools. Maybe I'm able to show it to you really quick. So this comes with the latest Kibana, right, or Elasticsearch. There's this thing called agents. And then when you go into agents, there's this agent, for example, but there's also, this is the default one, but this is tools, right? So tools, these are the predefined ones, and these are basically ESQL snippets. So tool is like, and you can create your own ones, right, in all kinds of MCP servers and so on. You just have a tool, like a procedure. You make sure it's doing safe things. So in this case, it's reads only, so it's pretty much safe. And then you can create your own agents or use the default ones, right? So I could ask, for example, like this thing, what are top 10 accounts and their average value? I don't need to know the data. It just does some thinking. It uses, for example, one of these tools, right? It fetches the data. It decides on its own which data to fetch or what tool to call. And then it, for example, can also generate stuff, right? So it depends, like MCP can do more, but it's actually the protocol. Oh gosh, I'm sorry. I'm sorry for you, I'm sorry for myself and for you. Yeah, so which one do you want to choose? The answer is, it depends, right? Of course. So I would suggest we use RAG when we predominantly want to read information and generate answers based off this information, right? Because it's safe, it's read-only, and you can also do some sanity checks on what you actually passing to this LLM, because maybe you don't want to share too much, right? And it works very well for unstructured data. See, I had just, chunky HTML stuff, right? It wasn't very well organized into, I don't know, like some super graph knowledge base, which also can be useful, right, for graph RAGs and so on. But it works really well with unstructured data. Whereas RAG is actually like this, integration, and you need to make sure you put strict security boundaries, right? Like with these tools that you've seen in Kibana, and it's really nice for this live structured data, right? For example, you can beautifully use these MCPs to fetch, for example, latest observability data. You can ask, hey, like, tell me what's happening to my, Kubernetes cluster during cluster hour, something like this, right? And then it can also like fetch multiple stuff, like maybe OpenTelemetry, maybe all the data. This is what it does, right? The thing is, why not both? And it's actually possible and doable, right? So MCP can actually be helpful in this R thing, which is the retrieval. So we can use MCP for retrieval. And then let's recap. RAG is basically a pattern, 3 phases: retrieve stuff, augment the context, right, and generate stuff. Unless you want to like retrain your AI model, for example, your LLM. But I don't think it's going to be the case, because it's like takes months or weeks at least. It's very much expensive, and you can't retrain it with every wiki page update of yours, right? And MCP is basically a protocol. And LLMs can therefore like interact with many things, even agent to agent, right? And get some data or like do some actions, okay? And together they can create a powerful combo, which is called MCP powered RAG, right? So we can use MCP to aid us with this retrieval. That's also doable. And also one more thing, retrieval for RAG doesn't always require a vector database, in my opinion. If you can retrieve your data in some other way, why not, right? But it also goes the opposite way. You don't have to be using vector search only for RAG. For example, vector search is great for e-commerce, right? We'll be showing that tomorrow, and other stuff. So both can live without without each other, but they really shine when combined together. Then there's this question, are you asking yourself this question, will I lose my job because of AI? Not really? You're not worried? Some are worried, okay? Someone said, I don't remember now who, but I very much like the answer. Probably you're not that likely to lose the job to AI, but you're more likely to lose the job to a person sitting next to you who can actually use the bloody AI. That's why I would like to encourage you to start playing with this stuff. You see, all it takes is just a handful of bash scripts, right? And a free version of a vector database, and that's it. Just toss some data in it and play. And with MCP, with RAG, with other stuff, see, maybe one day it will be useful for your product, right? And with this little announcement, if you have more questions related to Elastic, you can go to our forum, discuss Elastic.co, or join our Slack community, or we also run some meetups around the world. All of them are combined under this URL, elasticco.community. I work in community team, right? And I'd like to ask you for feedback. There's this app for Vox Days from Devox, right? Please let me know, apart from, oh, you should have had logged in before. I was, it's just this very nasty timing when I'm logged out after several hours. I'm sorry. I should have relogged before the talk, sorry. If you can't use this app, if you don't want to use this app, if you're watching a recording somewhere, please hit like and subscribe. It's not my channel. And let me know what you think about this talk. And nevertheless, with that, thank you very much.